This video is going to show another example of computing descriptive statistics in R. This time we're going to do problem 21 from chapter 3 in Siegel. So problem 21 is a little bit different than the other video I made today in that it gives a fairly small data set, and I think Siegel kind of intends for you to type it in. So the number of small electric motors rejected for poor quality per batch of 250 were recorded for recent batches. So our sampling unit here is a batch, so we know the number of defects. And he gives a long list. Now, I'd like to use this example for a way to illustrate another way to make a data set. So if I just say x, make a new object x, is going to be some vector, and we just type in these values 2, 7, 2, 3, 2, 7, 5, and so forth. To avoid typing them all in right now, actually I typed them in earlier. I just paste them, but I'm kind of expecting you to type those in just for practice. If you have a very small data set, you can type it in like that. All right, part A says construct a histogram. So if I say hist x, we see a histogram. Describe the distribution shape. Well, what we see is outliers. So this plot is clearly dominated by outliers. Most of the data sits here under 10 defects per shift, and it looks like you have a fairly big one and a really big value that are dominating this. Identify the outliers. Well, if I type X, we get a list of everything I just typed in. And so clearly there's a 25, that must be that value. And then there's a 41, which must be that value. So those are the two bad observations. Remove the outliers and construct a histogram for the remaining batches. So I think the easiest way to remove these would be to do something similar to what I showed in the other video. If I just say x less than 20, all right, that gives me an index, if you will, of which values are not outliers. And so you'll see this observation was an outlier, this one was an outlier. So if I say x sub x less than 20, it gives me the data set without the outliers. So I think we've been asked to make a histogram. So let's just do a histogram of x sub x less than 20. And what do we see? Well, I see something that is fairly, I would say it's a little bit right skewed. I know the solution says it's approximately normal. I think it's a bit right skewed. There's another command that I like. I haven't tried this for this data set, but if you do a plot of a density of this, actually one too many parentheses there. So plot of a density, I guess you could see where it might be moderately normal here, but maybe slightly skewed. Another way to evaluate skewness, this isn't really part of the exercise, but you can use the skewness function. And so the skewness is actually 0.36. Remember, a value 0 means symmetrical. Positive skewness, it's slightly positive, so it's moderately right skewed, but not by much. All right. Summarize the firm's recent experience with the quality of production. Well, I guess I'm going to go back to hist. Oopsie, hist of x. The majority of times we're doing very well. We have a couple really bad, we've had a couple really bad shifts, but most of the time we produce fewer than 10, in fact, fewer than 5 defects. All right, so let's move on to problem 39 in chapter 4. And this one says, use the data from problem 21 of chapter 3. Find the average and the median. So I suppose the simplest way to find the average and the median is just do a summary on x. Gives us a little bit more than what we need. And notice the mean is a bit higher than the median. The reason for that is the outliers have an effect on the mean. They don't really affect the median. Part B is remove the outliers and recompute the average and the median. So let's go do our little trick here, x sub x less than 20. And in this case, the mean and the median are about equal. So this illustrates how a couple outliers can inflate the mean, but the median is robust. And that's essentially the point of part C. Well, let's move on to problem 40 in chapter 5. And this says, use the data from problem 21 in chapter 3. Find the standard deviation and the range. Well, really the only way to find the standard deviation, simplest way, is just SDX. So the standard deviation is 7. Now we need the range. So one way to find the range is diff range x. So the range is 41. So we must have some days where we had zero defects, and we have our day that was really bad when we had 41. Remove the two outliers and recompute the standard deviation and the range. So let's go do our little trick. So x less than 20. So notice the standard deviation goes from 7 down to 2, which indicates how sensitive the standard deviation is to outliers. Now let's go repeat that for my range. So x less than 20. So the range is also terribly sensitive to outliers. And that's really about it for question 40.